Hi, so in this video I am going to talk about what happens when we react a metal oxide with an acid. So we're going to use sulfuric acid, which is a colourless liquid, and copper oxide, which you may know or may not that it's a black powder. And we're going to look to see what happens when we react these two together. So to start with, I'm going to measure 50 centimetres cubed of the sulfuric acid into a separate beaker. Okay, so I'll just leave the sulfuric acid there to remind you that it's colourless, and I'll pour 50 centimetres cubed into the separate beaker. Now, what I will do is put a little piece of white paper underneath the beaker so you can see the colour. So when we add the copper oxide to the acid, we will get a salt plus water. So we add a little bit. What you will notice is that the black powder will disappear or dissolve when it reacts with the acid. So when I stir this, you will notice that the solution will go, some of the black powder will disappear or dissolve. Now in this particular experiment, we want to make sure that all of the acid is totally neutralised. So we're going to keep adding our copper oxide until we have it in excess. That means that there's more copper oxide than there is acid. So that the copper oxide will react with all of the acid and there'll be so much left that we'll have some black powder left at the bottom. So again, just to make sure, I'm just going to add a wee bit more. So we'll definitely know that we've got more copper oxide than we need to neutralise the acid. Now, another way we're going to do this to check that all the acid is neutralised is we're going to heat it gently. Now, we're not going to heat the acid too much. We only want to heat it to warm up the acid to react the copper oxide with it. We don't want the acid to start to boil. So I have my Bunsen burner on a lowish heat. We're going to put it on just for a little time to get the acid to react with it. And what you should be looking for is to see, is there any colour change happening, or can we still see? We're making sure we can still see the black powder, that we still have the copper oxide in excess. So we just wanted to heat that up a tiny bit. We didn't want it to start to boil to get the acid fumes in the room. We only wanted a little bit. So what we need to do now then is to get rid of the extra copper oxide that we have. So copper oxide is what's called a base, which means it will neutralize the acid, but it won't dissolve in the water. So we're going to have some solid copper oxide left behind. And to get that out, we're going to filter the solution. So I fold up the filter paper the way you learnt when you were in year 8 or 9 and put it into the filter funnel, and then we're going to separate it by pouring the mixture through. Hopefully you can see this okay in the video. So hold it through. As I pour it, I can let go of the filter paper, and then what I want you to watch and see is the colour that's coming out. So in a beaker we've got the copper oxide left that was in excess. And over here, if I get another piece of white paper to put underneath the flask, you will see the colour of the solution that's been produced. So you can see we're getting a blue solution formed at the bottom. So we started with the sulfuric acid, which was colourless. We added black copper oxide to it, and now we've got a blue solution, which is copper sulfate that's formed. So we've got copper sulfate plus water. Now at the end of this experiment, what we might want to do is to try to separate the copper sulfate from the water, just to get the copper sulfate crystals. You maybe remember doing this in key stage 3. What we're going to do is just to evaporate off the water, and we'll be left with the copper sulfate crystals. This is a process that's called crystallization. So we take the copper sulfate solution from our flask and we pour it into an evaporating basin. So we've got our copper sulfate solution in an evaporating basin, and we will leave it. We can either leave it on the windowsill for a few days to evaporate off the water, or we could put it on top of a water bath and evaporate it quicker on the Bunsen burner. And when it evaporates off, we will get some copper sulfate crystals left behind. So the water evaporates off and we're left with the copper sulfate crystals. So this is the word equation for the reaction we've just looked at. We had copper oxide, which was a black powder. It was a solid, it was insoluble in water. It is known as a base because it will neutralize the acid, but it's not soluble in water. We had sulfuric acid, which was colourless, and they both reacted together and they formed copper sulfate plus water. So copper sulfate was a blue, and when it was dissolved in water, it was a blue solution. So it would be aqueous because it's soluble in water, and water is an L because it's a liquid. So that's our word equation plus our state symbols. If we were to do a symbol equation, our symbol for copper oxide is CuO, plus sulfuric acid is H2SO4, copper sulfate is CuSO4 plus H2O, and you can check to see if that is a balanced equation.